Good morning. This is the practice for the calculus, chapter 7 test. We're just going to start. First problem, formula for the nth term. So you're looking at the top and bottom. So the top here, I would write a note saying, hey, look, it's times 3 every time. So it's timesing by 3 every time. And the bottom is plusing 3 every time. So what does that mean? Well, when you plus 3 every time, and we're counting by n, starting at n equals 1 and moving on, plusing by 3 translates to doing 3 times n. And timesing by 3 goes 3 to the nth power. So I have like a 3 to the nth power on top and a 3 times n on the bottom, but that doesn't quite sell the story because we start at 2 right here. And we're always starting when n equals 1. So the first term has to be 2, so it has to be a 2 times 3 to the 1 power. Doesn't make sense. I would go 3 to n minus 1. This would make when n equals 1 is our first term, 2 times 3 to the 0 power, and it'd work from there. On the bottom 3 times n, again, doesn't work. I have to start with like a 2. So I would actually go 2 plus 3n. It's not n, it's n times 1, like this. So if you had started with 1, this would 0 out and start at 2, and then you're adding 3 every time. So that's one way to write it. It's not going to be a big part of the AP test. It would be like multiple choice, if anything. Moving on. Reason why each of the following integrals is improper. So to be improper, one way is it's got infinity. So A is because it's going to infinity on one side. Now, this one's improper because also if you do like a divide by 0 at any point on like the limits or in between, that's bad. When you plug in a 5, that's going to make it a 1 divided by 0. So that's why it's improper. And for this one, well, if you plug in -2 or +2, it doesn't make it improper. But when you plug in x equals 0, which is in between, you will get 1 divided by 0, and that's also bad. So it's in between both of those two, so it makes things improper. So you can be improper in one of 3 ways. We've mostly done this and this in class, rarely done this. If you actually had to integrate that, hey, let's just, do I want to integrate it? Sure, I'm going to integrate this one. Let's actually just integrate all 3, because Blanca's here and shook her head. You don't have to for this class, but I kind of want to see if I can. So let's do this. Number 1 right here, if you're integrating this. So, yeah, it's actually a smart thing to do. Integrate this, I get x squared over 2 from 0 to infinity. Now, technically, it's the whole limit as a goes to infinity, and then you switch this to a. I don't care. We're just going to put infinity. So if I did infinity squared over 2, maybe I'm supposed to care for the AP test. I don't know. Now here's the thing. This is just 0. That's cool. But infinity over 2 is infinity. And whenever you have an infinity answer, we say diverge. So number A diverges. Let's do with B. So since at the end, we can just, again, integrate like normal. Now if I integrated this, 1 over x squared minus 25, how do we integrate that? Oh, I was thinking that was going to be arc sign, but that's like 1 plus x squared. You know what this is? This is everyone's worst nightmare. This is fraction decomposition. Oh my gosh, I'm going to have to do this right now. Okay, so I'm going to do this work. I'm probably going to have to erase it. No, okay, so it's going to be like a over x minus 5 plus b over x plus 5. And, you know, 1 over blah, blah, blah equals that. So this is the blah, blah, blah. Not going to fit. You can figure it out, dudes. Multiplying it by the denominator, you get 1 equals a times x plus 5, because this will cancel, plus b times x minus 5, because this will cancel. I'm going to plug in x equals 5. This gives us 1 equals 10a. And then, so a, and that b goes to 0, so a equals 1/10. That's fun. X equals -5 is going to be 1 equals, this goes to 0, -10b. So b equals -1/10. Awesome. Fractions. Rewriting this, it's going to be the integral of 1/10 of x minus 5. It's from here. Plus -1/10 x plus 5 from here. Integrating those, it's actually going to come out to 1/10 ln of x minus 5 minus 1/10 ln of x plus 5. Oh, by the way, we're going from 0 to 5. Okay. So let's plug in these things. Okay, so again, this is technically the limits as you approach 5. So to make this work, because we're approaching it from the left side in between 0 and 10, it's really the limit as a approaches 5 from the left. And I put an a in here. So we're thinking as you approach 5, so you're getting slightly smaller than 5 going to 5. The reason I say that is because when we plug in the 5, I get 1/10 of ln of 5 minus 5. But ln of 0 is a bad thing. What does ln of 0 actually do? If you looked at a ln graph, it like does this thing. It's going down to infinity. So as you approach, as this value approaches that 5 and this absolute value, it's going to be approaching negative infinity. So this is technically 1/10 times negative infinity. Guess what? That's gross. So my answer, diverge. I don't even need to do the rest. Diverges. It's going to be the same thing. Oh, so 5, if you plugged in 5 here, it'd be 10. That'd be cool. But since this part right here goes to negative infinity, we're done. It diverges. There's no hope. I can plug in the zeros. Doesn't matter. Everything else works except for this first term. Yep. Cool. I'm going to pause here because I'm going to have to erase to make C work. Okay. I'm erasing. We're going to do C. Awesome. So this one, you have to split it at 0. So I'm going to write, so ignore these guys. Rewriting C. The integral from negative 2 to 0. 2x plus 1 over x squared plus x. And then it's plus the integral from 0 to 2 of 2x plus 1 over x squared plus x. You have to rewrite it this way. dx, of course. So when you're integrating this, and let's only integrate one first. Let's see what's going on. You integrate this. This is a u substitution because our u is going to be x squared plus x, and du, it's going to be 2x plus 1 dx. Life kind of works out nice. So this is the integral of 1 over u du, which is going to be ln of absolute value of u. This is ln of absolute value of x squared plus x. Both of these ended up integrating the same way. But we're just going to do one side at a time. Okay, so from negative 2 to 0. Now remember our same rules. It's technically not to 0. It's like the limit as a, I'm using a, actually I could have used b. Usually b's our top, a to b, right? Oh well. As we go from 0 to the left. And this would be like a. And technically this limit right here, this limit as, let's call it b goes to 0 from the right. And b was right there. If you're confused, I can explain that in class. Anyways, that didn't even matter. I was just going off topic. So you plug in a 0, I get ln of 0 squared plus 0 is 0. Just like we learned in the last video. I mean, okay, let's just do the rest of the math. Why not? Minus ln of, plug in negative 2, which would be 4 minus 2, which will be 2. And then, okay, that's it. But, dudes, this goes to negative infinity. So guess what? We already say diverge. It's important to do the math this way. I mean, I could have done the other one. If you just try to integrate this straight up, and here's why you have to split this. You must say, why do I have to split it? Well, if you split it right here, if you don't split it, you're going to integrate this and get ln of x squared plus x from negative 2 to positive 2. So you plug in 2 first, and you get ln of 2 squared, so 4 plus 2 is 6, minus ln of 4 minus 2 is 2. So you get this and say, oh, ln of 6 minus ln of 2 is ln of 3. Why is it ln of 3? Because you divide 6 divided by 2. But so you'd get an actual number, not diverges. This would be incorrect. If you looked at a graph of this, I don't know. Maybe I'll edit one in. I won't. Moving on. Any questions from the audience? Guillermo? Yeah, that's what I thought. Moving on. Yeah, that's right. Thank you. Evaluating this one. Okay, this is a little bit more reasonable. Again, same idea. Integrate right here. So I like writing that as 2x to the negative 3. That's because it's hard for me to do this without rewriting this. So it'll be 2x to the negative 2 divided by negative 2, which is the same thing as negative x to the negative 2, because these 2's cancel, which is the same thing as negative 1 over x squared from 1 to infinity. Technically limits. Hey, how's it going? We're all good. Just showing them how this works. So you plug that in. Negative 1 over infinity squared minus negative 1 over 1 squared. Okay, this has an infinity, but that's okay. This is the okay because we're over infinity, so this just goes to 0. And this turns to minus minus plus 1, so my answer is actually 1. What happened to the 2? Oh, they canceled out. So this does have an answer even though there's an infinity. So you just got to understand the infinity math. Moving on. Oops, too much moving on. So, oh wait, in case you needed it. No, you didn't. You could have paused the video. Determine convergence or divergence. Give a reason. If possible, find the sum. You can only find the sum for the geometric series. So let's take this one. You know this is geometric because it has the... is it geometric? Oh, I was going to say that, but it's not. I was going to say because it has the n. But there's also this n. We can't have both. So we got to try the nth term test. I'm sure that's why it's going to prove whatever. So n goes to infinity. E to the n over n. Well, if you plug that in, you get infinity over infinity. So L'Hopital's rule. Derive the top is e to the n, derive the bottom's a 1. And as n goes to infinity, that's going to be e to the infinity, which is infinity, which is not equal to 0. Therefore, it diverges by nth term tests. Awesome. Moving on with my life. This one, there's only one n. This is geometric. But since it's 5 over 4n, this is not 5/4. I'm rewriting this as the sum of, think of this as 5 times 1/4 to the n power. Because the 5 not being to the n power. That's the trap. Don't fall for it. So in this case, n equals 1. Notice it starts there, not at 0. That's the other trap. So my first term is when n equals 1. It's going to actually not just be 5, the coefficient's 5/4 because there's one of these. And my ratio r is 1/4. Oh, and by the way, since that ratio has to be between -1 and 1, and 1/4 is between that, we converge. Now, what does it converge to? The formula is the sum is a over 1 minus r. So 5/4 over 1 minus 1/4, which is 5/4 over 3/4, which is 5/4 times the reciprocal 4/3. Flipping that, cancel, cancel, the sum is 5/3 as a simplified form. Would this be satisfactory on an AP test? Sure. But a lot of times if they asked you this, it'd be multiple choice. And this would be the answer they show you. Alright, let's do 8. 8. Oh, I am geometric series again. Why? Because the n dealie, and that's my only n. Careful, this is on the bottom. So this might change things. This is not in the right format because we have to have a times r to the n power. R is on the top. So, okay, I'm going to show you what this actually is. So the r is actually, in this case, 3/2. You might be like, what? It says 2/3. Well, here's why. It's a fraction. Think of it as 4. This is to the nth power. Think of this as 4. I'm gonna rewrite this over 2 to the n over 3 to the n. Well, if you're dividing by that, that's like the same thing as multiplying by a reciprocal. So 4 times 3 to the n over 2 to the n. So 3/2 is actually our fraction because it's on the bottom. Don't fall for that trap. So our r in this case is 3/2, which is too big. This actually diverges. It's bigger than 1 because r is greater than 1. And that's bad. So watch out on formats like that. That was a good trick. The last one right here. Oh, look, that -1 dealie, so I'm thinking alternating series test. So first of all, does it have the -1 dealie? Yes. Is it getting smaller? The function without the negative 1, is it getting smaller? 3n, 2n squared plus 4. Okay, so I always look at a few numbers. The more of you do this, the better you get. It's like practice. So I'm going to plug in n equals 1 first. That would get 3 over 2 plus 4 is 6. You plug in n equals 2, I'll get 6 over 8 plus 4 is 12. Really? Okay. Do another one. It's the same. There's still 1/2. Another one, 3. So we get 9 over 3. 18 plus 4 is 22. Actually, the more you get, so these are even. That's okay, but we got to get smaller eventually. And we do get smaller eventually. It is getting smaller. Another reason I know it's going to get smaller is the degree on the bottom is higher than the degree on the top. So eventually, it doesn't even matter what these, this could be like 3 million on top. Eventually, this will get bigger on the bottom. And if the bottom gets bigger, then the number is getting smaller. Sure. And then the last check the limit as n approaches infinity of 3n over 2n squared plus 4. Now, hopefully you remember that with polynomials, if the higher degree is in the bottom, you know it's going to go to 0. But if you don't remember that, L'Hopital's rule, this would be infinity over infinity right now. So I derived the top bottom, 3 over 4n. If you plug in this, so I get 3 over 4 times infinity. And a number over infinity is just 0. So yes, so this is going to converge. Oh, wow, you can't see it. My picture's in the way. So I'm not taking that off. Converge by the alternating series test. Moving on. Show 4 terms in the general term of the geometric power series for this thing. Can I use a formula? I can. Oh man, you might be like, man, what do you do in this case? Well, so this is a tricky one. This is where if I start remembering things, things can help out. This looks like this format, especially when I have a 1 plus of something here, you might say, it looks like my friend a over 1 minus r. So, and it says geometric, and hey, that's the sum of a geometric power series. So whenever you hear this geometric power series, you see this, think of this format. So what I really have to do is use this to figure out my a and r, and I want to put something in the format like this. A times r to the n power. So I want to convert it, but I have this. Okay, so here's what you do. Well, what would my a be? My a is the top. What's my r going to be? R is going to be, it's 1 minus r, but I have a plus 3x, so r is negative 3x. Because like you break this positive into a minus a negative 3x. Sure, hope that makes sense. So if I did my summation notation thing here, notation, wow, long day. It's going to be x times negative 3x to the n power. From n equals 0 to infinity. Now, I can just leave it like this, but I'm going to try to write this nicer because it's weird having 2 x's. Let's use our laws of exponents. This is like x times negative 3 to the n power times x to the n power. I can break this up. Since I have, this is like x to the 1 power plus an x to the n, I can rewrite this as negative 3 to the n power times x to the n plus 1 power. I can rewrite it this way. I don't know if I need to, but I just did. Maybe that's useful. So I have to show the 4 terms. So again, we're starting, I'm going to count when n equals 0 is when we're starting as we do this problem. So n equals 0. You know what? I'm going to use this original format. That might be easier for me. No, I'm using this format down here. It doesn't really matter. You'll be right both ways. So when n equals 0, 4 terms. And go n equals 0, 1, 2, and 3. That would be 4 terms. N equals 0. This is going to be 0, negative 3 to 0. So 1 times x. So this will be just x. And the next one's going to be negative 3 times x squared. So minus 3x squared, your next term. Next one, negative 3 squared, it'll be positive 9, so it'll be plus 9x cubed, we're adding 1. And follow the pattern, it'll be minus 27x to the 4th. Where my generic term, again, would be this thing, so I could say plus dot 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 plus negative 3 to the n times x to the n plus 1. Or you could have done this generic term. You wouldn't have been wrong. Both terms would have worked. This is what my answer should be. Cool. Oh, interval of convergence. As if this wasn't annoying enough. We have to do some more, folks. So how do we do interval of convergence? Ooh. That's kind of weird with that x. So usually I look at this x right here. This is my ratio. Oh yeah, because that's my ratio, my r. Okay, this is okay. We can do this. It converges when your r is between 1 and negative 1, right? My r is negative 3x, so negative 1. You're going to do more of this later when we do ratio test. So it converges on this, but a lot of times when I do this, I want to isolate my r. So I'm going to divide everything by negative 3. And I'm going to get positive 1/3 is less than x. Oh, ho. Is it less than? No, it's not less than. When you multiply or divide by negatives with these inequalities, you flip the signs. I almost fell for it. So x is between positive 1/3 and negative 1/3. Yep, that's what you want to do. All right, moving on. Give the series for this one. Write the function for g of x. Okay, you might be like, oh, what does that even mean? Okay, this is a power series, like a geometric series. A function for g of x is like the a over 1 minus r. You basically are just writing this. So this is you're supposed to recognize this is like a geometric series and put in this function. All right, so what is our a and what is our r? Well, it's a generic term right here. So what would I put? Okay, so a is your first term. A is 3, because that's the first term. What is the ratio? What is being to the nth powered? Your r is 2x squared. How do I know? Because this generic term says so. So my function for this would be 3 over 1 minus 2x squared. So that sounds like that's really hard, but it's about knowing what that means when I say write the function. And that's something you're probably going to forget. So thing to review for AP test. Yeah, they throw that on. Now show 4 terms in the general term for g prime of x. Okay, so you're just deriving this. I'm going to do 12 down here. So derive this one. So I can rewrite, I actually want to rewrite this. So the trick is, though, they say 3 plus 6x squared plus 12x to the 4th. Okay. And you say, oh, and derive 4 terms. Well, here's 3. Well, g prime of x, the first term goes to 0. So this doesn't count as a term. That doesn't count. Boom. Deriving this one, you get 12x. And then this will be plus 48x third. I have 2 terms. So I got to kind of follow this formula here. You see what's going on? We multiply. What would be the next one in this? We're multiplying by another 2x squared. So another 2 times 2 would be 24x to the 6. The next one would be 48x to the 7th, or x to the 8th, if I'm following my pattern here. So now I got to derive this one. So this will be 6 of those. I think that's 144. Yep. X to the 5th. 48 times 8. 50 times 8 would be 400. So it'd be 392. X to the 7th. So that'd be my first 4 terms. Now the general term is just deriving this thing. So the general term was 3 times 2x squared to the nth power. Now you're deriving it in terms of x. So you're not deriving this n. It's not going to be an n minus 1 power. Is it? Well, kind of. So this is really weird to me in this format. I mean, technically, okay, n's a number. So we're going to follow a chain rule. So it'll be 3 times n to the 2x squared times n minus 1. And then wouldn't it be times the derivative of the inside as well? Actually, is it? It's got to be. No, it's actually not. You only derive the n's. Wait, no, we derive the x's. No, I'm getting confused with these n's and x's. So times 4x. And that would be our generic term. Does that make sense? Okay, if you start with n equals 1, you would get 0. Yeah, if you start with n equals 1, you would get 12x. So you get 3 times 1 times, this would go to 0 power, so 1 times 4x. So it would be 3 times 4x. 12, good. And then, yeah, n equals 2, you'd get 6 times 4 is 24. Times 2 would be 40. Yeah, that makes sense. I'm right here. So we had to chain it. Okay, if that was really trippy right here, I'm going to rewrite this in some way. So you know how this n power? I'm going to rewrite this as 3. I'm going to distribute that n power times 2 to the n, x to the 2n power. That's how you do this. So when you derived it, you only derived the x term. It'd be 3 times 2 to the n power times 2n. Oh, that doesn't save anything. Don't do what I just did. That doesn't make more sense. I mean, it's the same thing, but I just pretend I didn't do that. Just edit that in post. Thank you. No, I won't. 13, show the 4 terms in general when you integrate. Okay. So this should be a little bit easier. So I'm integrating g of x. So integrating 3 plus 6x squared plus 12x to the 4th. I have to just have 4 terms, 24x to the 6th. And then I can integrate my 2x squared to the n power. All right. So integrating this should be pretty easy. So it's 3x plus 12. Oh no, I don't even know what I'm doing. So it becomes 6x cubed over 3, which is 2x3. This becomes 12x to the 5th over 5. This becomes 24x to the 7th over 7. All right. So integrating this, and that's the first 4 terms. The general term when you integrate this one. So again, I add 1 to this exponent. That's really gross because we're inside of this, huh? So, what does that actually look like? I think you have to go back to this. Or you can follow this formula right here. It does look really gross in how they do this. I just wish I had a really good answer. I'm going to figure this out. So it's 3. How do I want to explain that? I probably have to go to this. Okay, it was me. Let's pretend it's me. How am I going to explain that? Good question. Okay, so it's going to be over 2n plus 1 because that's what we have to do every time, adding 1 to the previous 2n. And it'll be, yeah, I think you're just doing this. So 3 times 2 to the n, x to the 2n plus 1. I mean, that's really what it is. I'm just taking this that I crossed off earlier. It's gross, but that's how it is. I'm hoping that stuff's not really on the AP too much. I better double check that. So that's how you integrate, though. General term. I mean, this is legit. I've seen this a bunch. I don't really see this a bunch when I remember from practice, because that's kind of sloppy. But this is legit, and this thing up here. Okay. 4 terms, so we did that. Let's do 14. 4 terms in the general term for x squared. Okay, so 4 terms in the general term. Basically, take this g right here. Oh, no. I'm going to take this guy. I don't want everything, dude. I'm just going to multiply by x squared. So, and you only need 4 terms. So I'm going to go x squared times g of x is just literally x squared times 3 plus 6x squared plus 12x to the 4th plus 24x to the 6th. So then you multiply it by that, you get 3x squared plus 6x to the 4th plus 12x to the 6th plus 24x to the 8th. I mean, done. A general term? Ugh. So you just add 2 to the exponent right here. Your general term when you're doing that is just add 2 x's. How do I add 2 x's? So, I mean 3 2x squared to the n times x squared. That works. You're right. I wouldn't do any. Oh, you can't see it on my thing, but yeah, just add an x squared to the end. Multiply by another x squared. That's it. Multiply by another x squared from way up here, from this guy, basically. There. The big part is this. So they do this if they asked in different ways. I'm sidebarring here. They might say, write a polynomial up to the 6th degree. So the original one, if I said up to the 6th degree, would have been just these 4 terms. But since I'm multiplying by the x squared, it would end up being only these terms to go to the 6th degree. You wouldn't use this one. That might be the, ooh, they trip you up with that. I don't think I'd do one of the tests, though. But I've seen it before. Okay. Oh, geez, am I almost done? Oh, I'm not. Oh. Okay, time out. I need a coffee. Oh, well. Time to wake up. Just you know, if I get slower, just take that button, make it go and the 1.25 speed. Probably be better. All right. 4 terms in the Taylor series expansion for this one. That's super fun. Why would I do this to me? That's why it's extra credit. It's not extra credit for y'all. So let's do this. And then eventually we plug in 1.1. That's what it means. Oh, but only the 2nd degree. So 4 terms of the Taylor series centered at c equals 1. Again, so I'm going to write the Taylor series out. Would look like f of 1 plus f prime of 1 times x plus f double prime of 1 times x squared. Oops, x, not x squared. X minus 1 squared over 2 factorial plus f triple prime of 1 x minus 1 cubed over 3 factorial plus f to the 4th derivative of 1 x minus 1 to the 4th over 4 factorial. So working that out, we have to start plugging in a few things. Okay, so let's do my table. F of x, f prime, f double prime, f3 prime, f to the 4th prime. F of x, we know our function's 1 over the 4th root of x. And then when we plug in xc equals 1, it's just going to be 1 over 1. Now the first derivative, so this is the same thing as negative, so this is like x to the negative 1/4 power. The first derivative would be negative 1/4 x to the negative 5/4. The second derivative, oh geez, you're multiplying those, will be positive 5/16 x to the negative 9/4. That looks fun. 9/4. The next one, 45. 16 times 4 is 64. X to the negative 13/4. The next one, 45 times 13, let's do that. It's going to be 450 plus 450 plus 135 is going to be 550, negative 585, sure, over 6 times 4 is 240. Can you simplify that? Sure. Am I right? I'm not using a calculator. I'm going to believe I'm right. It's a negative 17 fourths. Here's the thing. X to any, when you plug in 1, these are all just going to be 1. This x to whatever power is 1. So it's just 5/16ths. 45/60ths. Oh, I could have simplified that. 45 simple, it goes down to 9 over, even simpler, I was saying it's 9 over divided by 5 is 12, which is 3 over 4. Oh, I should have done that. And then 3 over 4 times 13 over 4 could have been negative 39 over 16. It's negative 39 over 16. Oh, is it negative still? They should have switched signs. This is negative. This is positive. Right? Oh, this was negative 1/4. Positive, negative, positive. I skipped this one. Wow. Good luck if you weren't listening to me and trying to work out what I just did. You try to skip ahead. You're really confused right now. That's okay. So doing this polynomial. Polynomial fourth of x. F of 1 will be 1, doot. And then plus f prime of 1, negative 1/4 times x minus 1. Correction here. And then this will be plus 5/16 x minus 1 squared over 2 factorial plus negative 3/4 x minus 1 cubed over 3 factorial plus 39/16 x minus 1 to the 4th over 4 factorial. Simplify that. I dare you. You're not down. Okay, 16, you plug in the 1.1. Now it only wants the second degree. Second degree means I only go up to this guy right here. So if it, and this would definitely be a calculator question. So I'm going to say P2 of x is second degree. Actually, I'm going to say P2 of 1.1 to be technically correct because I'm plugging in 1.1. Be 1 plus negative 1/4 times, 1.1 minus 1 plus 5 over 16. Watch this. 5 over 32 is correct. If you don't know why, ask me later or think about it. The 2 factorial goes there. So here's what I got for an answer, and I could plug things in. Let's see if I try to do this by hand. Oops, my picture's in the way. So 1, it's going to be minus 1/4 times 0.1. I'm still going to try this. Why not? What else am I doing today? 5 times this is going to be 0.1 squared over 32. I can do this. So it'll be 1. This is 0.25. I'm going to switch this to decimals. Wait, that's probably a bad call. Now this is the same thing as 0.25 times 1. So minus 0.025. This will be plus 5 times 0.1, so 0.05 over 32. Sure, I mean, I'm not simplifying that. That was silly. So there I go. It's definitely a calculator question. And if it wasn't, I would have totally boxed this answer instead and not simplify. Yeah. I think the key part is understanding that you were only using the second degree to approximate that, not this whole thing. So, careful. Last one, elementary series. Okay, so this is what you mesmerize. And e to the x is approximately equal to 1 plus x squared over 2 factorial, x to the 3rd over 3 factorial. So when we're doing e to the negative x, we're just plugging negative x into all this. This will be 1 plus negative x plus negative x squared over 2 factorial plus negative x third over 3 factorial, and so on. Oh, unlike the elementary series. Oh, we want to write that the summation notation, right? That's really what we're writing. So what does this pattern look like from n equals 0 to infinity? Basically look at the generic term. Here's the generic term is x to the n over 3 factorial. So we can write negative x to the n over n factorial. Not 3 factorial, n factorial. You just write it like this. Done. That's all you had to do. That one's pretty simple. What's next? 3 terms of elementary series to approximate sin of 0.2. So sines elementary series. The first 3 terms. Sine is the odd, so we go x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. That's the first 3 terms, not to the 3rd power. And to approximate sine of 0.2, we put 0.2 in, so we go 0.2 minus 0.2 cubed over 3 factorial minus plus 0.2 to the 5th over 5 factorial. And we do some calculator magic. Ooh, and then we get something. I'll leave that up to you to type that in, because I don't want to. We're done. Good luck. Oh, how do I stop this? Wait, no, don't exit.